The second calculation step is computing the design flows. This is when the powers and temperature regimes are propagated back from the end units back to the production units. In this case, we have 3 end units, each of 100 kilowatts, but on different temperature regimes. If I compute my design flows, I can see that the software detects an error. So here it's detecting that this end unit is on a regime of 45-35, so is asking for a supply of 45, whereas this one is on 35-30. And so the software is saying there's a mismatch. It can't provide 45 here and 35 here without there being mixing circuits. We do have mixing circuits here, so how we could correct this is to tell this mixing circuit that it's actually receiving 45, and then it'll need to mix some of the return to obtain 35. So if we compute those design flows again, that error will now be fixed. What we can also see has happened is that on my circuit, so here there's 100 kilowatts coming from here. The volume flow rate has been calculated, which depends on the power and the delta T. Here now we get the sum of this circuit, this branch and this branch, and then we get the sum of this branch and this branch, so 300 kilowatts. We can also see that the volume weighted return temperature has been calculated. We've got 35 coming back here, 35 coming back here, 30 coming here, and so we get a volume weighted return temperature in full load of 34 degrees. We can also see that now the buffer tank has been assigned a design heat flow of 300 kilowatts, and the temperature regime has been adjusted to what it needs to be. Of course, you can override these and lock those values. The heat pump has also been sized accordingly in full load for that 300 kilowatt. Again, you can lock that to any desired value. However, the software automatically propagates the necessary powers back for the production unit to be able to meet that full load in design.